In this video, we are going to consider one complete case in SPSS. The data file survey 5 ED will be used to complete this analysis. The null hypothesis or the research question is there a difference in optimism score for the three group of people, the young people, the middle-aged person, and the old participants? The null hypothesis will be what? Null hypothesis will be the average optimism score mu of young is equal to the mu of middle age, m for the middle age, and the average optimism in the older person or the senior persons. So this is our null hypothesis, and in alternate hypothesis, we have at least two groups having unequal means. This complete hypothesis testing procedure is implemented in SPSS and data file survey 5 ED used. This file contains the actual data. The actual data of what? The actual data of the respondent's psychological adjustment, health, and well-beings. This real data file is the output of a research conducted by a group of students. How many variables are needed? We need the two variables. One variable is a factor variable or a categorical variable or name as an independent variable. So this is our IV, or the independent variable is a categorical variable with three factors or with three levels. What three levels are? Level 1, the young age group, 29 and younger. Between 30 and 44, 45 or above. These are the three different age groups. Other variable is a continuous variable. This variable is also known as a dependent variable, and our dependent variable is a continuous variable. The name of the variable is optimism score. The optimism score is a continuous variable or a quantitative variable or age groups. Age itself is a continuous variable, but we have coded the age into three groups. Young age group, the middle age group, and the older age group. So these three levels of the ages are to be used here in this analysis. TOPTIM is the name of the variable. TOPTIM stands for the total optimism in participants. Age GP3. Age GP3 stands for the age group 3. This is the second variable. This has three levels. The age group 3 level 1, 18 to 29, age group 3 level 2, 30 to 44 middle age group, and 3 is the senior age group, which is 45 and above. You can use recording. You can use recording into different variable or the record into different variable option. Record into new variable. This option in SPSS is available to make such type of grouping. Means quantitative variable can be converted into the groups, or this is also known as binning. Grouping or the binning. We can use these two terms. This is our first variable, TOPTIM. This is our second variable, age group 3. Age group 3 is continuous. TOPTIM is factor or string variable. This procedure is used. You have to apply analyze, compare means, analyze, then compare means in SPSS, and one-way ANOVA. These three options you have to click. In the dependent list, you have to choose optimism variable. In the categorical list, you have to use age group 3 variable. So these are the three steps. In group 1, in step 1, you have to click on the menu item, analyze, compare mean, one-way ANOVA. In the second step, you have to choose a continuous variable. I choose TOPTIM. TOPTIM is the first dependent variable is chosen. Then age group 3 is the next variable, which is a independent variable is checked. Then click on the options, descriptive. If descriptive table you want to see, then choose this option, check this option. If you want to check the homogeneity of variances or the Levene test is to be conducted, so you have to check this option. Or other options are also there. If you want to see the mean plot, so you can use the mean plot for that. Missing numbers, exclude case by case analysis. Case by case analysis, I already told the case by case analysis is a better option in SPSS for missing numbers. After completing the ANOVA, last option is post hoc analysis, and TUKI test will be used for post hoc analysis. Other option is LSD. LSD, you can also use LSD, least significant difference. LSD and the TUKI, these are the two options out of the several other options available in the post hoc dialog box. Click continue and check the results. This is our first result, descriptive measure. These are the sample means. You can see the age groups, age group 1, younger one, the middle one, and the older one. And these are the number of observation. The number of participants, which are 147 in the first age group, 153 participants in the second age group, 135 participants in the older or the senior person. Means are quite close to each other, and these are the sample means: sample mean 1, sample mean 2, sample mean 3. These are the 3 sample means, and these are the sample standard deviation within the group 1, group 2, group 3. Sample mean and standard deviation are referred to as a descriptive measure. Sample mean 2, sample mean 3, and this is the grand mean. I can use the grand mean. The grand sample mean is X bar. So X bar is actually the combined mean of all those 3, X3 bar. And 3 sample standard deviation, S1, S2, and S3. And this is the total standard deviation, S, in the overall data. So this is S, overall sample standard deviation. All of you are familiar with the calculation of standard error. It is S upon N root. S upon N root can be used for computing the standard errors and standard errors. You can see the standard error for first row age group is 0.375 divided by under the root 147. You will have this standard error. 4.145 divided by under the root 153. This is the second standard error, and so on. This is the overall standard error. These are the confidence interval. All of you are familiar by confidence interval. We can say that the younger age group, the population mean will lies within 20 year of age up to 22 year of age. This is called confidence interval for first age group, confidence interval for second age group, and we have a confidence interval for the overall data. This is the data of ages. This is the confidence interval for that. Minimum age is 7 and the maximum age is 30. The minimum age, I think it is not ages. I have no idea what this number is indicating. Now, moving to the next table. Next table is indicating total optimism is the dependent variable. Levene statistics is the Levene test. The DF1, degree of freedom 1, degree of freedom 2, this is p-value. Can any one of you have idea about the hypothesis with respect to this? The hypothesis with respect to this is the standard deviations in population of these 3 age groups are same or not. So sigma 1 is equal to sigma 2 is equal to sigma 3. These are the 3 population standard deviation. The p-value is larger than 0.05. We can conclude that the H0 of equality of standard deviation is same. So the assumption of homogeneity of variances is fulfilled by the data. Another way to check the equality of variance is an informal test. Informal test is what? Informal test is this. You can have the standard ratio of the two standard deviation. Which two standard deviation? The smallest standard deviation and the largest standard deviation out of these three. So the ratio, if the ratio is less than 2, we can assume the population standard deviations are same. So both agrees with the same hypothesis that the population standard deviation are same, and the assumption number 2 is fulfilled. Now this is ANOVA table. All of you are familiar with this table. This is sum of a square between groups. It is a known source. This is SS. SSTR. In manual calculation, we represent this as SSTR. Treatment, sum of a square between treatment. Our treatments are age groups. Optimism in age group. So age group, we are comparing the age group with respect to optimism. This is SSE, sum of a square of error, SSE, and this is SST, total sum of a square, SST. Degree of freedom can be obtained. 3 groups we have. The degree of freedom is 2. 435 observation totally we have. The 434 degree of freedom. And if I subtract this 2 from this, we have a degree of freedom for error. Similarly, mean can be computed by 179 divided by 2. This is 8333.951 divided by 432. It is 19. Now, as known source, S square, known source or the treatment, this is S square error. These two S squares have, we have to take the ratio of these two S squares. 89/5, 3 divided by 19.29, we have this F statistics. The p-value, if I look up this number into the F table with the degree of freedom 2 and 432, we have a p-value. This p-value is 0.010. This is an indication that the null hypothesis of equality of mean is not true because this p-value is smaller than 0.05. The null hypothesis of the equality of mean is rejected. Actually, this is an indication that the average optimism in all these 3 age groups are significantly different, or we have a significant optimism in these 3 age groups. This is the conclusion. Now post hoc is needed because the null hypothesis is rejected. So we have compared age group 1 with age group 2, age group 1 with age group 3. So we have the different hypotheses with these age groups. So H0 hypothesis, we are pairwise comparison. This is pairwise comparison. Mean of age group 1 is same as mean of age group 2. Mean of age group 1 is compared with mean of age group 3. Then mean of age group 2 is compared with mean of age group 1. And 2 is compared with 3. 3 is compared with 1. 3 is compared with 2. So we can write down the several hypotheses related to 2 means. So your H0 is mean 1 is same as mean 3. If we are comparing the group 1 with group 3. So we have to check only these p-values. These are the p-values for the different pairwise comparisons. These are the p-values for the different pairwise comparison. 0.3 indicate that the mean 1 is same as mean 2. This is age group 1 and age group 2. The mean 1 is same as mean 2. This hypothesis is accepted. H0. Average optimism in the younger is same as the average optimism in the middle-aged persons. But the second hypothesis is not true. Second hypothesis is what? H0. Second null hypothesis, this is H0, not H1. Second hypothesis is what? Group 1 is compared with group 3. The group 1 and group 3 are compared, group 1 and group 3. You can see that the p-value is 0.007. It is smaller than 0.05. So we can say that data provides sufficient evidence in favor of H1. The null hypothesis of group 1 and group 3 means are same is rejected. Now we can observe whether the optimism in the younger is larger than the older, or the optimism in the older is larger than the younger. So by looking at the sample means we can have this idea. The optimism in the older is 22.96 in my sample, and it is 21 point something. So clearly we can say that optimism in older person is significantly larger than the optimism in the younger person. So if we compare the optimism in the younger and the older, they are not same, and older have a higher optimism as compared to the younger. Now further comparison can also be do here. The remaining conclusions are same, and this hypothesis is also true. Optimism in 2 and optimism in group 3. This hypothesis also be accepted because the p-value is 0.230. So this hypothesis is true, this hypothesis is true, this hypothesis is false, because optimism in the group 1 and group 3 is significantly different, and we can say that the optimism in the older person is significantly larger than the optimism in the younger person. This comparison is given here. You can read this slide because all of the information that I explained in the previous slide is written here. Homogeneity of variance test, Levene test. Levene test is compared by 0.05, and the p-value of the Levene test is 0.475. Sig value stands for the p-value, and you compare this p-value with 0.05, we can say that the variances are same because the p-value is greater than 0.05. And homogeneity of variance is fulfilled. If the homogeneity of variance is fulfilled, then we can apply the ANOVA. ANOVA is here. The output of ANOVA, you can see degrees of freedom is marked, and different values of 0.03 and 0.001. So we can use these p-values to be compared. So by post hoc test, we have to compare the group-wise means. Group-wise means I already defined. So you can read this slide because over this slide, the conclusion of the post hoc analysis is given. Multiple comparison is also the post hoc. Sterics. If you see the sterics in a post hoc test, steric means significant. Sterics means significant. In output, we have sterics. I'm showing that steric here. This steric is this steric. The mean difference is significant. Significant are what? This is significant because there is a star here, and this is group older group. This is younger group. Older group, younger group is significant. And one more time we have significant, and that is here. This is significant. The older group and the younger group. The older group and the younger group are significant. This is significant, older and the younger. Otherwise, all are insignificant. The sterics give you the very clear-cut perception how this is. This conclusion is to be made. Now, multiple comparison, the conclusion of multiple comparison is here. Mean plot. Mean plot is indicating that there is a very high difference in mean. The mean 1, the mean 2, and the mean 3. But these means are very close to each other. This is due to the scaling, that we have a higher scale than this is indicating that the very high is significant. So this is indication that this mean and this mean and this mean very high differences we have, but actually we have a very small differences. These differences in this graph is misleading. The reason is high scale is chosen. This is described here, mean plot. The mean plot is misleading. This descriptive is shown here. These three means are very close but significant. We cannot say that the population means are same because group 1 and group 3 has a significant difference in optimism. Eta square is a term which is used for indicating the reliability of result. Reliability of the result can be, this is known as effect size. Eta squared is the effect size. If we have a higher value of effect size, that is an indication that the null hypothesis is rejected with the very high differences. If we have a very small effect size, that is indication that we have rejected the null hypothesis by very close or very small differences. So we have computed the eta square or the effect size here in this example. In this example, the effect size value is 0.02. This effect size value is very small. That is an indication that the three means are significant, but their differences are not too high. They are different, they are significant, but their differences are close. So it means very closely it is rejected. So there will be, in certain cases, we can have accepted the null hypothesis. Now this warning is shown here. Why? Because these three means are very close, but the mean plot is indicating that these means are very different. That is a misleading situation. Means are significant, but not too differently. Yeah, or the differences are not too high. That is why the eta square is 0.02. If the eta square is 0, the mean will be equal. The eta, if we have a very high value of eta square, the mean will be very highly significantly different. This is the way of writing the conclusion of one-way ANOVA. So you can see that how the output of the one-way ANOVA is to be published in the articles. So the international journal have some standard of writing the outputs. This is shown over this slide. The one-way ANOVA between group analysis of variance was conducted to explore the impact of the age on the level of optimism. The life orientation test LOT participants are divided into the three groups: the younger age group, the older age group, the middle age group. There was a statistically significant difference because the p-value of ANOVA is less than 0.05. So we can say that there exists a significant differences in the average optimism in the three age group. Post hoc analysis is conducted. The result of the post hoc analysis is group 1 and group 3 have a significant difference, while group 1 and group 2 is insignificant, and group 2 and group 3 is also insignificant. The eta square is 0.02. That is the very low effect size, is indicating that the null hypothesis of ANOVA is rejected with the very small margin. That is an end of this presentation. And in the next chapter, we will consider analysis of variance two-way ANOVA. In two-way ANOVA, we have two known sources of variation and one unknown source, which is known as one error. Unknown source is referred to as error. So one error and two known sources. Two known sources means one quantitative variable or one scaled variable is required, and two nominal or the factor variables are required. Two Two-factor variable. So totally 3 variables are needed: 2 nominal variable, 1 scaled variable, if we want to apply analysis of variance two-way technique. That's all for this video. Thank you very much.